This video is going to talk about how to do the dot product between two vectors. So if you have a vector, let's say u is component form u sub 1 comma u sub 2 as the vertical component, and v equals v sub 1 comma v sub 2. Let's say those are your two vectors. In order to do the dot product, which is just u times v, but we call it the dot product, all you have to do is multiply the horizontal components, u times v sub 1, and then you add it to u sub 2 times v sub 2, and that is what you get. Now, just so that we're clear, u sub 1 times v sub 1 is a number plus another number, the product of the two vertical components. So one thing to know is that your result is not a vector but is a number, or as some people may call it, a scalar. So it's not too terrible to do the dot product. You just have to recognize that your answer is not going to be a vector as it is when you add or subtract vectors together. So take, for example, let's take these for example. Let's say that u is 5i minus 3j. Let's say v is 6i plus 4j. And those are our vectors in linear combination form. And so let's just do, for question number 1, let's just do u times v. Following up above, we're going to multiply the horizontal components. So the horizontal components are the 5 and the 6. And so we're going to do 5 times 6. And then we're going to add that to negative 3 times 4. So 5 times 6 is 30, plus negative 3 times 4 is negative 12. 30 minus 12 is 18. Boom. That's your scalar. So that's the dot product. It's 18. Let's do another one. Second one. Let's just do the dot product of u times u. Here we go. Get ready for it. So we're going to multiply the 5, and that's the horizontal component, but you're going to multiply it by itself. So 5 times 5 plus negative 3 times negative 3, because use the same thing. And so you get 25 plus 9, which is 34. And if you think about it, this is awfully close to the magnitude of u. If you're to do the magnitude of u, it is, right, 5 squared plus negative 3 squared, which is 25 plus 9, and then it's 34, but then you square root it. So one thing you might see somebody do is they might express the magnitude of a vector in terms of the dot product. So you might see them say the magnitude of u is the same thing as the square root of the dot product of u times u. The last thing I would say about this, because there's not too much to say necessarily about the dot product, because it's pretty straightforward if we're just doing simple dot product stuff, is you need to remember you're always multiplying the components together. Even if you are in a class where you're doing three-dimensional vectors, you just multiply the x components, the y components, and the z components, and then you just add them together. So it's pretty straightforward. But let's just say you had 3 of them. Let's say you had u times v times u again. So, and let's say these two are in parentheses, so we should do those first, right? So u times v, we already know how to do that. But once again, I'll just write it 5 times 6 plus, right, that's u times v, plus negative 3 times 4. And so 30 plus negative 12 is 18. But if you notice, that's just u times v. And now they want to add, or not add, but multiply by u again. So now we're going to do 18 times u. Well, my answer now that I'm multiplying 3 vectors together is actually going to be another vector, because I can only multiply 2 of them together first, and that gets me a scalar. And then minus 3j, And then when I multiply the scalar by the vector, I get another vector. So 18 times 5 is 90i minus, and then 18 times 3 is 54j. So one thing of note, when you multiply two vectors together, when you do the dot product of two vectors, you're going to get just a number, and that's going to be a scalar. But if you multiply three of them together, then you'll get another vector back, and so forth. So if you do 4, you'd get a number. If you multiply 5, you'll get a vector. Another thing that we can do with the dot product that you might see somebody tell you is that you can find the angle between two vectors using the dot product. It's not just the dot product, but it's the dot product and the magnitude, but here we go nonetheless. Here's a formula that you might need. Cosine of theta equals u times v over the magnitude of u times the magnitude of v. And this formula can be used to find the angle between two vectors. So let's just say that you have vector u is, let's go with 3, 4. And let's say vector v let's keep the numbers nice, 5, -12. And you've got to find the angle between those two vectors. You're going to need a calculator, because at some point, in order to find theta, you're going to have to do the inverse cosine. So I've got my calculator open even though you can't see it. So the first thing we're going to do is we're going to find the dot product and the magnitudes. You're obviously going to need those in order to use this formula. So the magnitude of u, if you know your Pythagorean triples, 3 squared plus 4 squared and then square rooted, is 5. And then if you know the magnitude of v, say it out loud with me on the count of 3. 1, 2, 3, 13. So there we have it. Now to do the dot product, we're going to do u times v. And remember, we're going to do the horizontal components multiplied together. So 3 times 5 plus, right, 4 times -12. So what do we got? We have 15 plus -48. So I think that's going to be nice as -33. So that's the dot product. Alright, so to use that formula, we're going to just set it up. So the dot product is -33. So cosine of theta equals -33 over the two magnitudes multiplied together. So 5 times 13. So we've got cosine of theta equals -33 over 65. And so you just need to do the inverse cosine in order to get the answer. So theta is going to equal inverse cosine of -33 over 65. And whatever your calculator says that is the answer. Make sure you're in degrees, unless your teacher wants it in radians. But I'll do it in degrees just so that it hopefully can work out the same. So I've got inverse cosine going into my calculator, -33 divided by 65. And I get theta is 120.51 degrees. There may be a handful of ways in which you can find the angle between two vectors, right? So just so for my visual people who are watching this is a terrible line, but anyway, let's just assume that's 3, 4, and let's assume this is 5, -12. What did we just find? Right, we found this angle right here between these two vectors, and it's 120.51 degrees. Alright, so that's the dot product. That's what you can do with it. one of the things you can do with it. You can do a lot of stuff with it, but I'm sure your teachers will continue to teach you on what to do. All right, have a great day.